In this portion of the math module, I'm going to talk a little bit about what I consider to be one of the more important tools that you can have in your toolbox whenever it comes to solving chemistry problems. That's dimensional analysis. So dimensional analysis is a common tool that's used throughout general chemistry and in beginning chemistry. Essentially, it's the math of unit cancellation and ratios. It's great for unit conversions. It's great for moving through different units. For example, you can't directly go from a mass to a volume unless you have a specific ratio. And one of the big places that we see it is the dreaded word that most students don't like, and that's stoichiometry. So the basis of dimensional analysis in algebra, let's say I have x, and I divide it by x. This becomes 1. If I have x squared, and I divide it by x, this becomes x. Why? Because I have x times x divided by x, and so one of these cancels out. The same thing happens whenever I have, say, 1 inch and 1 inch. The inches cancel out. So what the basis of dimensional analysis is what's on top cancels with what's on the bottom. And in typical dimensional analysis, we use ratios. So a ratio is a constant that says you have x of one thing with a unit, and it's equal to y of another thing with a unit. And these units can be different. And then I can rewrite this as a ratio. So I would have x, whatever the unit is, divided by y, the unit. Now, sometimes in chemistry problems, a lot of things we deal with are word problems. You'll see words like per, or you'll see things like is always equal to. But per is a very common one. In fact, percent has it right in the name here. So that's essentially saying whatever your unit is per 100. So if I have an 80% ethanol mixture, that means for every 100 mils, the percent, cent being 100, I have 80 mils of ethanol. Many of the ratios that you're going to see are in things like metric conversions. So for example, there are 1,000 milliliters in 1 liter. You could see these things in imperial conversions to metric conversions. For example, there is 2.54 centimeters in 1 inch. This being a metric, this being an empirical number. So we can use these values and actually do multiple steps as needed. Now, I use what I call the dimensional analysis grid. Some instructors aren't a fan of that, and that's fine. I like the grid because it's a very nice visualization of what you're doing. So the way that I draw the grid is the first thing I'll draw a horizontal line. I'll then put my first number that I'm going to work with. So for example, I want to go from meters into feet. So whatever on the bottom cancels out units. Whatever's on the top multiplies units. So going back to my example above with x, I'll put it in a little box here in the upper right-hand corner. If I have a dimensional analysis grid with something like this, these two multiply, and then it's divided by that x, giving me a final answer of x squared. It's important to remember that as we move across with these units, because the units that are on the same as the top and the bottom will cancel out, but the numbers will still have to be multiplied and divided. So if I want to convert into feet here, I'm going to have to go to centimeters first in order to use my conversion here. So I have every 1 meter has 100 centimeters. Ratios can be written in either way. So I have 1 meter over 100 centimeters, or I have 100 centimeters over 1 meter. As long as those numbers stick together, they can be flipped upside down if need be. So this will put me into centimeters, but I don't want to be in centimeters. I want to be in feet. So I add another line where I'm going to break things up and use another ratio. If you learn this a different way from another instructor where you do parentheses, that's totally fine. This is just the way that I demonstrated. It's math. As long as you do all of the appropriate connections, it doesn't matter how you get there. Okay, so in this case, my next ratio has 2.54 centimeters to 1 inch. So I have centimeters on the top. I'm going to need centimeters at the bottom in order to get rid of it. And that gives me to 1 inch. I don't want to be in inches. I want to be in feet. So now I know, just from experience, that I have 12 inches in 1 foot. So now before I do any math, I do a double check to make sure my units are going to cancel out appropriately. So I have meters on the bottom and meters on the top canceling, centimeters and centimeters, inches and inches, and I'm left with feet. Now I take each one of these and I multiply all the way across the top and divide by everything on the bottom. My calculator answer is 5.675853 feet. But that's not the correct answer. We're almost there. We always need to make sure that we keep our significant digits in mind. Ratios like this and this are counted numbers. Therefore, they have infinite number of sig figs. This is also the case with inches to centimeters. So my governing bit here, because all I'm doing is multiplication and division, is going to be 3 sig figs. So here is my last sig fig. I look at the number. This provides us an excellent opportunity to round even. So I can either have 5.67 or 5.68. And since it's a 5, and that gives me an 8 as my even number, I round up. One of the beauties of dimensional analysis is it kind of gives us a check to make sure that we're doing everything correctly. In this case, I am going to go from a unit of volume to one of mass. So I can't just go directly from feet cubed to grams in this case. I need to actually do a little bit of dimensional analysis. It also gives us a chance to find these, what sometimes students feel are hidden ratios. When I have a number like density, what this is saying is I have 8.94 grams for every 1 centimeter cubed. So that's another way to look inside of a problem to find ratios for every blank, per blank. If it's written like this means 1 is at the bottom. But this also comes and shows us a danger when we're using dimensional analysis and kind of a self-check. So let's say I have 2.78 grams of copper, and I'm going to start my dimensional analysis grid. The first thing I'm going to need to do is get into centimeters cubed, right? Because the only thing I have to cancel out with grams is here. So I have 8.94 grams in 1 cubic centimeter. Now I have a ratio here where I can go from centimeters to inches. So I have 2.54 centimeters in 1 inch. Now let's just take a pause here and look at what my unit would be. Grams would cancel out with grams, but centimeters cubed does not cancel out with centimeters, right? In fact, if I were to stop here, my unit would be centimeters squared inches, which is definitely not where we want to be. So in order to make this all agree, I need to take this value and I need to cube it. I recommend that when you're punching this into the calculator, you do this as a separate set. Cube it and then use it for your calculations. Don't try to take a number and then cube it and then as you're working your way through. I also don't recommend with a calculator that you do a bunch of series of calculations as one step. Just go through and hit enter every single time. So now I need to get into feet cubed. So that means for every 12 inch, I have 1 foot. Again, I need to take a pause here. So I would look and I would have inch cube or inch squared and times feet, which is not what I want to have. So I need to cube this as well. And so I plug this all into my calculator. I have 2.78 times 1 times 1 times 1. And then I divide it by each one of these as an individual step. So in the end, I end up having, with proper number of sig figs, 1.0 0.10 times 10 to the negative 5.